Right. So sit down. Where are the rest of them? Huh? L2? Huh? No, that is okay. Where are the other guys? ಬರ್ತಾರೆ ಅದನ್ನು ಕಡಿಮೆ ಮಾಡುತ್ತಲ್ಲ. ಬಾಲಾಜಿ ಆಫೀಸಲ್ಲಿ ವೈಟ್ ಬೇಕು. Right. Start. What should I do? Like it's already 9:15. Right. So whatever we discuss today, it is very, very important with respect to your self-study or with respect to a general understanding of microcontroller, or if you consider with respect to an understanding of multitasking, or with respect to an RTOS, operating system. So today we are putting a base for all this. You have to remember this, or like you have to understand this thoroughly, so that like you correlate this understanding with next semester and next semester understanding. From operating system, when they say multitasking is done by OS. This task will be run on this for some time, and then this task will be run on. Please come. Open door. Open it. Another task will be run on this processor for another some time. When they say that, what do they mean exactly? They will not express there. We will tell here, you should correlate this with that study. So till now, whatever we have discussed about RAM, ROM, SFR register in some port register. SFR, not all the registers. Please come. So we have discussed about port, how to handle a port, how do we transfer data from the microcontroller outside world to the outside world, or from the outside world to the microcontroller. You understand what is outside world? Outside world is putting one LED and one switch outside the microcontroller, interfacing to the pin, then like interacting with us. Whatever goes inside, we can understand only if there is a software to understand. See that? You're understanding what I'm saying? If I say add A, B, I can see what happened to register A, what happened to register B, only if I have that register window. If I just have a microcontroller kit, I cannot see that. You're getting what I'm saying? To see what is going inside a microcontroller, I should send the value to outside world, where we exist, like we and inside a microcontroller should interact. What is happening inside a microcontroller, if we want to know, it has to come out of the port. There is no other way. You're understanding this? Otherwise, it has to be a software wherein which like we can simulate and see. Right now, what we are doing in the lab is that. Is it clear? There is another way wherein it's called the debugging mode. Right? The world famous, right now widely used debugging tool is JTAG. What JTAG does is, it scans all the register values before execution of instruction, after execution of instruction, and send it on one port or serial communication. You getting what I'm saying, right? Whatever you are seeing on the register window now, A value, B value, whatever R0, R1 value, all those values, PSW value, that is possible in simulator. If you want to do that in the hardware and check what is happening, you need a JTAG debugger. What JTAG debugger does is, it scans all the register values before execution of an instruction and sends it on the serial port to the computer, right? After the execution of instruction also, it checks it. What JTAG does is, whenever there is a change in event, whenever some event happens in a microcontroller, inside a microcontroller, it scans registers and sends it to the computer. If there is no JTAG, there is no means of debugging it. User has to write a program to send the value to the outside world. Is it clear? Is this clear? Is this concept is clear? Right. So in this regard, we have discussed most of the part. What we have left out is port 3, some pin values, special pin values are there. For example, there are two timers, T0, T1, two interrupts, interrupt 0, interrupt 1. And then we have write and read. Write and read we have discussed. Write and read we have discussed. So what else is there? RxTX. So three functions are there: timer, interrupt, serial communication. Three functions are there: timer, interrupt, serial communication. Two pins for timers, two pins for interrupts, two pins for serial communication. Today we will discuss on the timers. Okay? How the structure will be? What is the pin number for timers? No. 14? 15. That is third, fourth pin. Fourth pin and fifth pin. All deceased people. Is it trending from your teacher to the student? Not good here. Yeah. Right. This two pins, which represents a timer, also have a connection in SFR. SFR, you have T0 represented as TH0, TL0. Check it and tell me what is the address for these two guys. T1 is represented as, which one? 8A is this? 8A. 8C. Similarly, TH1, TL1. 8B. When it is 8D. Right? These two pins will correlate with these two registers or these four registers in SFR. Right? We said T0 and T1 are 16-bit registers. Because internally this is a combination of two 8-bit registers. Everything is 8-bit register now. Except PC, we don't know what is the structure of PC, that's all. The remaining, all the register, every memory space in 8051, it is 8-bit only. Right? Now we should see how do we handle these two registers through these pins. How do we handle these two registers through these pins? Okay. I will tell you before starting this, I will tell you one quick, come sir, please come. Before starting the discussion on this, all of you, do you remember what is a counter, up counter? Binary up counter, not random, simple, very simple binary up counter. All of you remember, right? These two registers are nothing but like 8-bit up counters. These two registers are nothing but 8-bit up counters. Now if you connect this output to this one, then it will become 16-bit up counter. They are only up counter, no down counter. You are getting my point? Please note, whatever we are discussing, the way we are discussing, it is not there in any textbook. Again, this is a combination of 4 textbooks. Right? I am just combining all these concepts. So I wish you should write down so that it will be ease of reading. Okay? You are getting what I am saying? These are 8-bit registers, TL0 and TH0 are 8-bit registers connected in an up counter manner. So if I take the output of this 8th register, 8th flip-flop and connect it to the next one, it will become 16-bit counter. Only up counter. There is no down counter concept. Up binary counter directly. So what is the maximum value we can expect and the minimum value we can expect when it is in 8-bit? When it is 8-bit, it's starting from 0, 0. It might go maximum up to FF. When it is 16-bit, 4F. Right? The maximum value is that. Beyond that, what happens? Beyond that, what happens? All FF, then what happens? It comes back to 0, 0, 0. This is exactly the same thing in the binary counter also. We have discussed a 3-bit counter. When we discussed in DEC, it is a 3-bit counter. Starts from 3 zeros, goes up to 3 ones. After the 3 ones, like it comes back to 0 again. Correct? Same phenomena here. Same phenomena. Okay? Right. What happens now? How do we work with this, guys? With this, there are 2 more registers called as TMOD and TCON. What is the address for this? TMOD is 89. Okay. What we do is we do reverse. TMOD will put it in the box and address is 89. TCON 88. These are all linked concepts. These 2 pins, these 4 registers, these 2 registers all together forms one phenomena called as timer phenomena. What is timer phenomena? It is nothing but like 3-bit up or 8-bit or 16-bit up counter. Only up counter, you should remember. There is no down counter concept. Right? Now, you understood these 2 things, what it is inside these 2. What inside these 2, first we understand that, and then we will see like TCON is timer control. TMOD is timer mode setting register. TMOD is timer mode, timer controller. How this will control these things, how this will set the modes for this. This is what we will see now, right? So what we discuss now is TMOD. TMOD register. As I have told you, everything is 8-bit. This is also 8-bit, which starts with gate, counter or timer. Then we have CR flag, M1 and M0. Four bits, same thing, will repeat. Gate, counter or timers, M1 and M0. This is for timer 0. This is for timer 1. Only with this physical understanding you can write a program. If you don't understand this, you cannot write a program. So this becomes very base of the discussion. Where is it? Right. So this is the 0th bit. This is the 7th bit. Okay. Right. So what we do is like, this is same duplicate. Guys, listen now. You are written. Yeah, listen to me. This is same duplicate here. This part is to set the mode for timer 0. This register, how it has to operate. This part is to set the modes for timer 1. How that has to operate. Right. In this, what we do is we'll take the gate. Let's see what is gate. Gate can take 0 or 1 value, right? When it is 0, it is software control. When it is 1, it is hardware control. When it is 0, it is software control. When it is 1, it is hardware control. You just write this. When we discuss TCON, we'll correlate. What do you mean by this hardware and software? Now, for today's class, we'll not discuss on hardware control. We'll discuss only on the software control. What do you mean by that? In the next class, when we discuss hardware control, you should remember this gate has to be 1. Okay? So, yeah, this is the concept. What is this? We'll discuss that. Right. Next one, counter or timer. Again, it can take 2 values. Counter or timer. Again, it can take 2 values. When it is 1, when it is 0, it is a timer. What do you mean by timer and counter difference? What is the difference between timer and counter? They say when this bit is 0, it acts as a timer. When this bit is 1, it acts as a counter. What is the difference? Huh? Count timer does not? Where should it has to go continuously? There are only maximum values are 16 bit. Yeah, that is the difference. But timer and counter, sir, timer is actually internal phenomena. Counter is external phenomena. How is this? I will tell you. Both are counters. Finally, both are counters. Both will count. What is timer? This is also counting, right? With a delay of 1 second. You can also do counting. 1, 2, 3, 24. Like after that, like you can reset. You can also count it, but it will not be exactly 1 second. Yours is also counter. This is also counter. But this has a proper defined delay of 1 second. Is it clear? Right. Now exactly coming to 8051. When I say a timer, it is the same 8-bit registers. 8 flip-flops arranged in up counter manner. Given a clock pulse, you know what it counts, right? When I say counter, what it counts? How many clock pulses are coming inside, it counts that. So these clock pulses will come from the crystal frequency of the 8051. When I say it as a counter, these are connected to this door sensor. Right? Whenever somebody enters inside, there will be pulse generated. That pulse is connected to P3.4. That pulse in the sense like what it is exactly. P3.4 will connect one IR receiver. Another side, like we are emitting the IR, we are connecting the IR emitter. So when there is continuous pulse or continuous connection between this, there is no pulse generated. When somebody comes in between, there is the signal from going from here to here will be cut. That means when there is nobody, it is high. When somebody comes here, it will go down, and then he passes, then it goes back. Is it clear? Is this clear? So if this pulse is given to the timer clock, counter clock signal, then it acts as a counter. Did you got this? Both are counters. One counter will get the signal, clock signal from the crystal frequency of the 8051. The another counter gets a signal from P3.4 or P3.5. When it is getting a signal from P3.4 or P3.5 like this, we will say it as a counter. You have to set it as a counter. If you are willing to operate this counter with the clock frequency of the crystal frequency, related to crystal frequency, then like you have to set it as a timer. Is it clear? Timer is purely internal phenomena. It is an internal phenomena. Counter deals with external phenomena. Is it clear? What is the difference between timer and counter? Right. Next one. M1 and M0. M1 and M0. Any doubt in this? Timer, counter, clear, right? So you can think like this: external interfacing, counter; internal, it is timer. You have to set it. Oh, that is very important. Right. So now M1 and M0 are mode setting bits. Mode setting bits. They can be 0, 0, 0, 1, 1, 0, 1. Okay. When they are 0, 0, this register, listen to this, this 16-bit register will act as a 13-bit register and act as 13-bit counter or timer. Why is this required? This is required because 8048, 8031. Do you remember, like initially we said 8051 is an architecture ranging from 8031 to 8952. 51. You remember initially we told it 8031, 8048, all these are what is called as successor or predecessor. Predecessor. Previously designed before 8051, properly designed, these are all designed. And they are already in the market. To give a compatibility between this and that, they have given one mode which is called as 13-bit mode, that is mode 0. It is 13-bit mode. Though it is a 16-bit register, it acts like a 13-bit register and do the counting for 13 bits only. Clear? Next one. Mode 1 is a 16-bit register. Mode 1. The 16-bit, this is normal 16-bit register, put 0, 0, 0, 0 here, give a clock pulse from the clock frequency or from the counter, it starts counting. The maximum value it counts is 65,335 or 535. What is FFFF? 65,000. It will not be in the decimal, it will be in the hexadecimal. You should convert that to this one. This is the maximum number it can count for 16-bit. Right? Next, mode 2. Mode 2 is 8-bit reload mode. 8-bit auto reload. This is auto reload. This is auto reload. Auto reload. What happens in this? You written? Now listen. TL0 we put some value. It is 8-bit, right? 8-bit mode. That means this only is acting now. If you put 0, 0 here, it will count up to maximum FF. Again, when it finishes FF, it takes the value from TH0. Whatever the value you want to give it to this, you put it in here. So what happens, if you want to start it from 32, put it 32 here, it will start from 0, 0 to FF, after it reaches 32 to FF. Next 32 to FF. It goes on like this. This is called auto reload because once it reaches its maximum value, it will be loaded with TH value. Once it reaches its maximum value, it is loaded with this value. That is why it is called the auto reload mode. Auto reload mode. You can write TH loads TL0. TH loads TL0. After 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 reaching its maximum possible value. After reaching its maximum value. Right, done? Last one. This is also 8-bit timer. This mode 3 is again 8-bit, but this time it is a split timer. Split mode. What is split mode? TL0 is an independent counter from TH0. They are not connected. For both of them, the clock is separate. This will get a different clock, this will get a different clock. Right? There are two counters now. In split mode, there are two counters. Is it clear? Split mode in the sense, if it is in the split mode for both the timer 0 and timer 1, there are totally 4 counters. Totally 4 counters available. Okay? This is about T mod. Now we have to discuss on T con and connect with T con and T mod. And then again connect with T0 and T1. Any doubt in this? Any doubt in this? Right. I have to rub this part. Huh? Mode 3? Why? How? No, we'll come to that. We'll come to that. Right? We'll discuss on T con now. In what is it? T con register. Now we have discussed on T mod. This is T con. Okay. What is T con? T con is again a 8-bit register which has this following values. What is that? TF1, TR1, TF0, TR0. IE1, IT1, IE0, IT. IE or TI? IT1. Done? Done? First one, TF1. TF1, TF0 are the same. These are related to timer 1. These two are related to timer 0. Similarly, timer 1, timer 0. Right? We'll write it here. This is timer 1. I don't think it is required. It represents by itself. TF0, timer 0. Yeah. Timer 1, timer 0. Okay? What is TF1? TF1 is a overflow flag indicating if it is in, guys listen to this, if it is in 16-bit timer, that is mode 1, goes from some value that you have initially put, like let's assume 3342, from this value it reaches up to maximum FFFF. Once it reaches this, it will go to 0000. When it goes from FFFF to 000, TF1 will become 1. You're understanding? So TF1 is timer overflow flag. Timer overflow flag. Whenever timer reaches its maximum value and goes to next minimum value, then TF1 will be 1. Okay? Timer overflow flag. Write it in the brackets. Timer overflow flag. Okay. below that, you're right. It is hardware set, software clear. It is hardware set and software clear. What is the meaning of this? It sets by hardware by itself. 8051 structure is so that when it reaches its value, maximum value, and goes to again next minimum value, it sets by itself. Hardware set. But software clear means we have to clear it. We have to write a program in one instruction to clear this. Well, how do you write it? CLR. Set bit for setting it, CLR for clearing it. CLR. If we use CLR TF0, TF1, it will be clear. You're getting what I'm saying? That is the software clear. TR1. TF1 and TF0 same concept. This represents to timer 0, this represents to timer 1. That is the point. That's all. Okay? Next one. TR1. TR1. Timer start. Timer start bit. Timer start bit. Written. Set and cleared by software. You have to set it by software, clear it by software. Set and clear by software. What is this timer start bit? When you make this as 1, when you set it as 1, then this counting starts. When you set it as 0, counting stops. It is like a button in your stopwatch. That button, if you press that button, then it will become 1. The timer will start. When you press that button again, when you leave that button, it will stop. You are getting what I am saying? In the stopwatch, you will have one button. If you press and hold it, it will start. Timer will start. Then you leave it, it will become 0. Timer will stop. Is that clear? Which timer? This one. What do you mean by timer will start? No, that I know, yaar. Internally what happens? Clock gets supplied to the counter. Till then they will not be supplied to the counter. So what it is, how can you think about this? There is an AND gate. AND gate. For AND gate, one input is a clock, another input is a TR1. You're understanding? There is an AND gate for which one input is a clock, another input is a TR1. If that TR1 is 1, then only clock goes ahead. If that is 0, then go ahead. Clear? Right? Done. Next one. IE1. IE1. This is where important comes. Please write it down. External interrupt 1. External interrupt 1. It's a edge triggered interrupt. Please write this. Please write this. We'll discuss. It's a edge triggered interrupt. I can say it is a negative edge triggered interrupt. High to low is a signal. That is negative edge triggered interrupt. It's a negative edge triggered interrupt. It's a negative edge triggered interrupt. Set by pin 3.3. Pin 3.3. Interrupt 0, 1. Interrupt 0. See, P3.4 and P3.5 are timers. T0 and T1. Above that, P3.3 and P3.4 are there. Sorry, 3.2 and 3.3 are there. So 3.2 is interrupt 0, 3.3 is interrupt 1. So IE1 is connected to interrupt 1. If, guys listen to this, if on interrupt 1, that is pin number 3.3, there is high to low pulse, then this will start. And this works only when gate is 1. Hardware control. What do I mean by software control? See, making TR bit as 1. Guys, listen to this. Then you can write it. TR1 is software controlled. You are setting it by the pulse on this one. So hardware controlled. This is hardware controlled possible, yes, if gate is 1. Is it clear? Below that you mentioned. This works only when. This works only when. Only when the gate equal to 1. This works only when the gate equal to 1. Then IT1. IT1. This is interrupt type 1. Just write it. We'll discuss it like maybe later. Interrupt 1. Interrupt type 1. IT1 is interrupt type 1. We'll discuss this later. Why is because I believe it is similar to TF1. When it reaches its maximum value, this is similar to TR1. Yes, listen. This is soft controlled. This is hard control. When gate is 0, this will act. When gate is 1, this will act. You can also write it below here. Gate is 0. Gate 0. This will act. When gate is 1, this will act. This is hardware part, this is software part. So please write IT1 as just an interrupt type 1. We'll discuss it. Hold on to that. Is it clear now? All the bits in this are clear? We said like gate, software and the hardware, like we'll discuss now it is clear. Timer counter is also clear. Modes are also clear. In this TF1, TR1, TF0, TR0 are clear. IE1 and IE0 are same concept. IE0 is connected to interrupt 0. IE1 is connected to interrupt 1. Whenever there is a high to low pulse on that pin, then like timer will start. Is it clear? Right? Now, we'll try to write one small program relating all these concepts. Color up this. Mode 3 we have to discuss. In mode 3, then listen. In mode 3, what we said, there are totally 4 possible timers available if we set it in mode 3. Okay, that means all are independent now. But how do we start it? We have only TR1 and TR0.